Hey friends, we are in chapter 3 and we're looking at fractions and decimals. One of the things you're going to really want to be able to do in this section is long division. And so if that's been a problem for you, definitely we need to talk, or if you let me know, I can make a video of how to just do long division. So I'm going to be assuming that you know long division. Follow along, let me know if you have any questions. So we're going to get started with operations with rational numbers, fractions and decimals. So our vocabulary today contains 3 words: terminating decimal, repeating decimal, and bar notation. For each of these, I'm going to give an example. I'm not requiring you to write a definition, though I will verbally give you a definition, all right? So let's get started. So what we have, our first term is terminating decimal. This refers to a decimal that ends. So an example, a decimal that has a finite number of digits after the decimal point. So the number 4.35794 done is actually considered a terminating decimal. Terminate means to end. 0.34 done. 0.91, negative 0.91, all of these are considered terminating decimals because they end. All right. Our next term, repeating decimal, we'll do here. A repeating decimal is a decimal that doesn't just continue on with a pattern, but it definitely repeats. So you can take a chunk and it constantly repeats. So after the decimal point. So examples of a repeating decimal would be 0.434343. You get the idea, on and on. Or you might see something like 0.9712111, because after that 2, the 1 continues to repeat. So that's considered a repeating decimal. Notice that repeating decimals, at some point in time after the decimal point, you're able to take a value or a couple of values and just kind of repeat them. And so hence the term repeating decimal. Okay, so a more convenient way to write a repeating decimal is to use bar notation. So to write this number in repeating decimal form, I'd write 0.43 with a bar at the top. The bar is used to represent the part of the decimal that repeats, so that chunk that I referred to earlier. And to rewrite this number as a repeating decimal, I would have to write 0. You could always write a 0 in front if there's just no numbers in the ones place. You could put a 0 there. 97121, and the 1's repeating, so I'm just going to put a line over the 1. Make sure you're careful as to where you put your bar, because that could definitely change the value of your repeating decimal. Let's go ahead and look at a couple of examples. So here's our first example, example 1. Like I said, we need to know long division, so we're going to be exercising our long division skills here. Here's what I like to do before I even start with a problem like this, because 7/8 is a decimal. Some people might feel uncomfortable with that, but what happened if you had 10/5? How would you write this as a number? Most of you know that this really means 5 is being divided into 10. So sometimes when I see a number like this, right, like a fraction, I know that I can just drop my 10 right here and do the division. 5 goes into 10 2 times, and so the answer to that is 2. I want you to think about the same thing here. When we have 7/8, it is a division problem. However, the 8 is going to be my divisor, and the 7 is going to be my dividend, the thing under the division sign. So I'm going to have a 7 here. And so with that, I'm going to just rewrite it over so I have a little bit of space. Let me do that one more time. One more time. Okay, so I'm going to rewrite this over so I have a little space. There, that's better. And I'm going to put a 7 here. Now 8 does not go into 7, which is cool. So what we're going to do is add a few zeros. I may use them all, I may not. And instead of treating this as a 7, I'm now going to look at these two places, the 1's place and the 10's place, and treat this as a 70, because this would be 7, the number 7 would be 70 tenths. I don't want to overtalk this, so I'm just going to do the thing. So 8 goes into 70 how many times? Hopefully you recognize it goes in there 8 times. 8 times 8 is 64. I'm going to subtract that. And now what I have left over from this value here, 70, is going to be 6. And now I drop a 0. 8 goes into 60 how many times? 7 times, because I know 7 times 8 is 56. And when I subtract The fact that I get a number that is less than 8 lets me know that I found the maximum number of numbers that can go into, so I found the correct multiple of 8s that goes in. Because if I got a remainder of 8, that means another 8 would be able to go in. Okay, I'm trying not to overtalk it. All right, so the next thing I'm going to do is drop another 0. And now 8 goes into 40. How many times? 5. And that's exact, because 5 times 8 is 40. I have no remainders, and I'm done. I just happened to put 3 zeros. I didn't know it would work out. Sometimes you have to continue to add zeros on and on and on. So this is an example of a terminating decimal. It stopped. There was nothing else to do. There was no remainder, no more need for putting zeros at the end. Let's look at example 2, which is going to give us an opportunity to look at repeating decimals. So here, we're going to write a fraction as a decimal using bar notation to show the repeating decimal. So let's take this first one. Again, when I have 5 over 12, it helps me to remember that the 12 is going to stay there, and I'm going to just drop the 5 right underneath the division bar. So this is my divisor, and this is my dividend. And again, I'm going to add a couple of zeros and see what happens. Now, 12 does not go into 5, so I can put a 0 there. But now I can think, does 12 go into 50? And it does. It goes in there 4 times, because I know that 4 times 12 is 48. When I subtract that, I get 2, and I'm going to drop a 0. How many times does 12 go into 20? I hope you guys are saying 1 time right now, and it does only goes in once. 1 times 12 is going to be 12. When I subtract that, I get 8. I'm going to add a 0 because I still have a remainder. Remember, when we are changing our fractions to decimals, we're not looking to have remainders. We're looking to continue out as far as we need to go to see if it's repeating or to see when it will terminate. All right, so I'm going to put a 0 down here. How many times does 12 go into 80? I believe 6 times, because 6 times 12 is 72. When I do that, I get 8 again, and so I'm going to have to put a 0 here and drop the 0, pardon me, not the 8. And wait a minute, didn't I just do this? Isn't this deja vu, right? You realize I've got 12 goes into 80. I did that 6 times. Now I got the 80 again. It's going to be 6 times. And it looks like, all right, let me just do it. Stop talking. 72, subtract, get the 8. Golly gee willikers. This thing is happening over and over again. So this tells me that nothing's going to change. I'm going to continue to get these 6s. So the answer here, let me use a black pen so you can see it. The answer here is 0.416 with the repeating bar, or with the bar notation over top, just the 6, because that's the only thing that repeats. Does that make sense? Let's take a look at this next one. All right, so this next one is 2 over 11, and it's negative 2 over 11. I'm going to do that, drop the 2 down here, but I'm going to rewrite it because I felt like this got a little complicated over here. So I'm going to put the 2 goes down here. And all right, so what does that mean? I'm just rewriting it again. 11 divided into 2. And I'm just going to put a negative at the top to say that my answer is negative. Is that all right? So now I'm going to do the thing. I'm going to do the division. How many times does 11 go into 2? It cannot. Let me add some zeros to the back. Notice I line up my decimal place right over top of the place where the decimal is for my dividend. So 11 goes into 2, cannot do. 11 goes into 20, oh yeah, 1 time. 1 times 11 is 11. When I subtract, I get 9. And I put a 0 down. 11 goes into 90 8 times, right? Because we know our 11 times tables, 11, 22, 33, blah, 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 88, right? 8 times 11 is 88. Subtract, rock a 2 down here, put a 0 here because we don't stop. We can't stop because we won't stop. No, keep it to myself. All right, 11 goes into 20. 1, this looks suspicious. 1 times 11 is 11. Subtract, I get 9 again. I see this happening before, chablitos. Drop the 0. I know I don't have enough room, but that's okay because I think I know what's happening here, right? You guys see this repeating situation? So we see that our answer is negative 0.181818181 forever and ever and ever. And so I'm going to write my answer up here as negative 0.18, and since this is the repeating portion, I'm just going to put a bar there. We feeling all right? I hope so. We have a few examples. Let's keep going. So over here, this is really the same concept. You don't have to copy all of this down, but let's just get the details of it. So according to the USDA, teenage boys should consume an average of 2,700 calories per day. About 360 calories should be from milk. To the nearest hundredth, what part of the teenage boys' calories should be from milk? So we've got 360 out of 2,700. And what we need to do, if it's to the nearest hundredth, I'm using the wrong color. If it's to the nearest hundredth, what we're doing is we're going to change this fraction into a decimal, and we're going to do that quickly. First thing I'm doing is dividing the top and bottom by 10, so I get 36 over 270. So I'm going to reduce this as much as possible. Then I'm going to pull the division move in order to get the decimal. So what I realize is that when I'm looking at this 36, I'm like, oh, I know that 9 goes into U 4 times. And when I'm looking at this guy, I know that 9 goes into U 30 times. And it looks like I can reduce this one more time. Did I get that right? 9 goes into 27. Yeah, 30 times. All right, good. So then now what I'm going to do is reduce this further and get 2 over 15. So now I'm changing this into a fraction. You remember how to do it. 15 on the outside, 2 on the inside. Rock it out. 15 goes into 2, never, but 15 does go into 20 one time. I'm subtracting, I get a 5. Drop the 0. 15 goes into 50 3 times, because 3 times 15 is 45. Subtract, I get a 5 again. Oh my gosh, deja vu, it's happening again, not again. So let me use a black pen, 0.1333 repeating, but it says to the nearest hundredth. This is the 10th, this is the hundredth, and this number after it is the thousands, and I have to look to that number to see if I need to round up or keep it the same, and I'm going to keep it the same. So to the nearest hundredth, it's 1.3. 0.13 part of the diet needs to be milk, according to this USDA study. Let's look at example 3. So example 3 is a little bit more straightforward and simple in terms of what we need to do. We just need to figure out which one is greater, which one is less than, or are they equivalent? And the best way to do that is, or one of the ways is that you can do a couple things. You can obviously use a calculator. To use a calculator, you would just take 1 and divide it by 4, changing this into a decimal, get it? So you can compare decimal to decimal. You could also change this decimal into a fraction and compare it, but most people don't like that method. So I'm going to do it the way most people like to do it. So I'm taking 1 over 4. I'm going to change this. I know you guys already know this. 4 does not go into 0. 4 does go into 10 2 times. 2 times 4 is 8. Subtract, get 2, drop the 0. 4 goes in that 5 times. So I get 0.25, not shocking. So which one is greater? Is 0.25 greater than 0.2? And I hope everybody is saying, come on, Dion, this is embarrassing. We know this already. Just like that with a British accent. 0.25 is greater than 0.2. This next one over here, a little bit more complicated. We have 2 fractions, so let's go ahead and change these 2 fractions into what we need them to be. So we've got 5 over 8, negative 5 over 8, so we know our answer is going to be negative. I'm dividing 8 into 5, and let's do our thing. So 8 goes into 5 no time, 8 goes into 50, 6 times, 48, subtract, get a 2, 0, 8 does not go into 20, not evenly anyway, it does go into 20 2 times, and that gives me 16. When I subtract, I get a 4. I'm feeling good about this. 8 goes into 45 times. So this, using a black pen is helpful. So this gets translated into negative 0.625. Let's see what this guy is. So we're going to do the other side next. So 6 over 9, by the way, can be reduced to 2 over 3. So I'm going to use that. So really I'm taking negative 2/3, which was negative 6 over 9. Walk with me, chablitos. And I'm going to divide, let's get this pen a little bit thinner. I'm going to divide 3 into 2. And some of you probably already know this. 3 does not go into 2. 3 does go into 20 6 times. 6 times that gives me 18. Subtract. There's that pesky 2 again, right? So it's 6 repeating. So this guy, sorry about that, this guy over here is going to be negative 6.6 repeating. So which one is greater, the 0.66666 or the 0.625? Hopefully, I know this is looking really crazy, 0.625 negative or negative 0.66666, and that's just repeating. Which one is greater? Well, this is kind of funny. When we're dealing with negative, the smaller looking one, the smaller looking absolute value is greater because it's closer to 0. than the, right? So this one is greater because they're negatives. Got it? All right, that's all I'm going to talk about right now. I had another example, but I don't think you want it, so I'm not going to give it to you. I can't wait to see you soon. Let me know if you're having trouble with long division. I can't wait to help you with it, and I will see you soon. Thank you so much, guys. Bye-bye.